Hi everyone. As said, I'm Katherine from AECOM, and we've done a project with a confidential client at this stage from government, looking at how they could address end-of-life tyres in their area. Unfortunately, the report is not publicly available, so I'll have to refer to them as the client and the region, but I'm hoping you'll still find the findings of this study interesting. So just a quick agenda. So we'll just do a bit of an introduction to end-of-life tyres to get us warmed up, and then look at the problem statement, why the client saw a need to look into management of end-of-life tyres, what the opportunities available for the client were, and then what options we looked at that they could implement in their region, and an assessment of these options to identify a preferred approach or an implementation plan. And those will be the findings and the next steps and conclusions from here. So just a bit of an introduction to what a tyre is, and we'll focus a little bit more on a car tyre than a truck tyre in this scenario, as the client thought addressing car tyres in the first instance was where they would start. So an average car tyre is made up of rubber, which includes the carbon black and silica and additives, with 78%, and then steel and textile materials. So if you were to take an end-of-life tyre, how long do you think it would take to turn into an end-of-life tyre on average? How long do you think your tyres last? A year? Anyone else? So on average, depending on the driver, as some people may do more burnouts than others, kilometres travelled, road conditions, on average a car tyre lasts approximately 5 years. So if you were to take the average person driving from the age of 17 to maybe 77, if your eyesight stayed with you, you'd use about 48 tyres in your lifetime. And when you scale that up, that turns into a lot of tyres. So we'll look at that in the Australian context. In Australia in 2015-16, about 56 million tyres, end-of-life tyres, were generated in Australia. So that is, in the context of maybe size for you guys, that's not one, not two, but approximately 3 MCGs worth of tyres. So in Australia currently, about 63% of these tyres are still being landfilled or in an unknown destination, which might be stockpiling, illegal dumping, or illegal landfilling in unknown places. Some tyres are exported for energy or shredding overseas, and 10% nationally is recycled locally. So the client saw an issue here with the number of tyres being generated and not enough tyres being locally recycled and recovered. So as I stated, predominantly they're landfilled, dumped or stockpiled, and landfilling represents a significantly missed opportunity for recovery of the rubber, steel and textile materials for other uses, which I'll talk about in a moment. Also, the mismanagement of tyres is the main concern for our client. So we've heard a lot over the conference about fires recently in the industry. A tyre fire is particularly hazardous because it generates a toxic smoke. It burns for a long time, and it takes a lot of resources to maintain that fire safety from the local fire brigade services. It also produces potential pollution from groundwater and surface water runoff. So with our client, we saw the opportunity for the client to both be proactive with the resource recovery of tyres and a leader in the industry, which is one of their motivations. Also to support the local economy, they were really looking at a local approach, not focusing on the export, but to look for where they could stimulate their local economy, and implementing a resource recovery program to a defined industry group, because the loop between tyre manufacturers, retailers, you return your tyre to the car tyre change, is a very closed loop system which could be easily addressed. There's also national legislation very supportive of resource recovery, and there are a range of market opportunities for tyre recovered products. So I'll just talk about a couple of those. So as you may know, tyres are commonly used as an artificial turf or in sporting fields. So that's probably the main market that you may have come across. But they are also being developed as rubber adhesives and explosives, used in civil works as a shredded material, as drain aggregate, and then can also be used as permeable pavements. So cycleways or pedestrian tracks that actually has a greater infiltration of water, which has some positive environmental impacts. There's also the energy use, which we'll hear about in a later discussion today, and the use of asphalt road construction materials. So there's a lot of options available, which are being developed in Australia. So based on that, we undertook an options assessment and identification for our client of what could they do to increase resource recovery of tyres in their region. So we identified a long list of options, and then we held workshops with industry and government to kind of nut out the strengths, weaknesses, opportunities and threats of these options. We also then undertook a triple bottom line assessment of the environmental, economic and social impacts, and we looked at a risk assessment. So quite a detailed assessment, which I won't have time to go into in 20 minutes, but I'll talk about the strengths and opportunities common to all options and also the risks of the options. And then I'll look at some of the indicative costs of implementing the option. So what options did we assess? We looked at regulatory options, co-regulatory and market-driven, which has been spoken about a lot, creating that market pull for the products to be used in the region. So with our regulatory options, we looked at landfill ban. The client already bans tyres informally in the region, but formalising that so that there's a trigger for industry, a landfill levy for disposing of tyres, and an advanced recycling fee, which is passed on to the consumer. And then legislating processing and recycling requirements such as stockpile limits, storage times, and environmental controls and licensing to try and create more structure around that hazard from stockpiled materials. We also looked at the co-regulatory approach, and that would be supporting the current product stewardship of tyres in Australia, and then the market-driven approaches, so where could our client assist in that market pull, so developing a specification for use of tyre-derived products in their road construction, as they are responsible for a significant number of major roads and minor roads in their area. We then looked at support and promotion of other tyre-derived industries in the region, and also looking at export of tyres. So the strengths and opportunities common to all options were obviously the increased diversion from landfill, but also the potential environmental impacts from reducing the impacts of stockpiling and fires. And also the opportunity to create a positive political profile for our client, benefits to the environment, and then a high quality of materials collected and recycled. Another positive for our client was jobs creation in the region, as they're looking for a centralised approach. So I'll just talk you through some of the risks of each option, as they're important to address when implementing any strategy. So we looked at the landfill ban, landfill levy, and the risks common to these options were around potential negative reaction from industry and the public, and that may lead to transport into other states and regions, but also increased illegal dumping, which would need to be addressed. The advanced recycling fee, we looked at implementing it at the point of purchase and the point of disposal when you have your tyres changed, and we did a look further on about what cost would be applied to each tyre in order to recover each tyre. So obviously with this there's also a potential negative reaction from the consumer about paying extra, and it may also drive people, to other regions and areas to buy their tyres at a less rate. So that was very important. And also the risk of free riders who may put additional fees on their tyres to community that's not educated about the government legislated fee. In terms of the legislated processing and recycling requirements, these were looked at as just a way of reducing the stockpiling limits and the hazards from those, and also illegal dumping. Again, there's the negative reaction, and may result in people taking tyres outside of the region, which is not the goal of the client, to make it someone else's problem, but to encourage the tyres to stay within the region. So increased illegal dumping would be an issue. So there's the current tyre stewardship program, and the client is very supportive of this program, but they're looking for some short-term effective recycling rates, whereas they see they'll continue to support the current co-regulatory arrangement. However, they were looking for how they could increase that diversion rate faster than staying with just the voluntary approach. So our next option looked at our client, our government, supporting the construction of a tyre shredding plant in the region and the potential use of these tyre-derived products into local industry manufacturing. So we had a look at what the cost of a plant would be in the region. It was approximately $1 million to shred the tyre down to 50 to 150 millimetres, with $100,000 per year to maintain. And this is specific to this region, so it may differ across client areas. And then what would that implication be for our client based on the number of tyres, end-of-life tyres, and also purchase tyres they were generating. So if the government was to subsidise this at the point of sale, it would cost the government 60 cents per tyre, or passed on, or 75% at the point of end-of-life tyre generation. So the reason those numbers don't match is because traditionally there's more and more cars on the road every year, so more cars are being purchased, which means more end-of-life tyres, less end-of-life tyres versus new tyres being purchased. So our assumptions also were looking at a payback period of 3 years within the client's jurisdiction. So the uses for this material are in construction, aggregates, and building applications. So they would support and promote tyre-derived products through their procurement, but also through developing local specifications. So what were the risks of this option? Obviously there'd be some administrative hurdles, changing their procurement standards and those of industry. Cheaper imports are a risk for use of tyre-derived products, and the perceived health concerns which exist with some use of tyre-derived products overseas, but the results on that are still outstanding. The next option we looked at was actually developing a specification for use of tyre-derived products in their road construction. So our client maintains and builds a significant number of roads per year. So what would the cost be to incentivise industry to build a tyre crumbing plant within the region to meet the needs of our clients' tyre-derived product for road construction? So the facility would cost approximately $1 million for this $5 million for this region, and $500,000 per year to operate. So what would this mean per tyre? It would be $2.75 at the point of generation per tyre, or $3.70 at the point of disposal per tyre. So again, that same difference in cost due to the number of tyres being purchased versus end-of-life tyres generated. And they would use the product as a bitumen spray, and this would be set up through a market pool arrangement where the government would establish the procurement policy that this material must be used in their road, and it would be a common arrangement. Using this method, they would use approximately 40% of the end-of-life car tyres generated in the region, which would be a significant diversion from landfill for our client. But there do exist risks, even with this option, administrative hurdles within the government agency to change their procurement policies, and also the security of supply. So really having that contract negotiation up front to ensure that the products are being accepted by the recycler and that the government is actually using them and they're able to maintain that security of supply. Cheaper imports, again, are a risk which would need to be negotiated, and the potential health and safety impacts during construction of roads. The last option we looked at was the export of end-of-life tyres, and I know we've talked a lot about export and dependence on overseas markets, so I think the risks are quite clear and the reasons we wanted to steer away from this option, but really looking for a local solution which could be maintained locally and have that, not have that reliance on external markets. So what was our solution that we came up with? So it was actually a combination of a number of those options, as none on their own could balance the risks. So the implementation plan that we established was a series of consultation at the beginning with industry and with consumers to look at price sensitivity around those numbers that we came up with per tyre. If the government was to pay for that, or if they would pass that fee back on to the consumer as an advanced recycling fee, would consumers drive interstate out of the region to buy a tyre because $2.70 is too much. So having a look at that just to make sure we don't drive consumers outside of the region for those products. So after doing that consultation, it would be the first stage of regulatory intervention with implementing the advanced recycling point of purchase or at the point where you change your tyres. So that the decision around that comes down to the legislation about where you actually have the power to put that in. With our client, it looks, they may have the power to put it in at the point where you dispose of your tyre. And then you develop the market. So as I said, through those procurement changes within government, they would implement their procurement policy for tyre-derived products for their road materials, and also support the development of industry with the use of tyre-derived products in other areas. The final regulatory intervention would just be to concrete that industry understanding that landfill bans would be formalised, and there would be limits put on stockpiling so that material wasn't being collected but not passed on to the recycler. Okay. And so just the final findings is the combination of those options were agreed based on the ability to increase diversion from landfill. We didn't look at the total numbers for each, but the 40% for the market specifically for road construction and the assumed use in other tyre-derived products would be beneficial. Reduce the environmental impacts, which was an overall goal, and an innovative and sustainability profile for the client, which is very important. And one of the final important ones was the job creation in the local region. So just some conclusions, just to summarise. So we found that we looked at the tyre crumbing option. It would be $2.70 per tyre. Would anyone be willing to pay $2.70 per tyre to know that it's being recycled? Yeah. So it's not very expensive. So we found that it was a reasonable price, and industry was to this as well, and were very keen to have a plant in this area as long as they could make it financially viable for themselves. So there was a good discussion between industry and our client. Local investment efforts, again, and coordination challenges would still be a challenge. It is a government body, so there would be the administrative hurdles of changing policies, procurement policies, and also managing that fund, the money in and the money out, and making sure it's handled responsibly. So the client is currently considering the findings of this study, and hopefully it will be publicly available soon, so I can say their name. And AECOM sees this as a potential model for other jurisdictions, including state governments and larger local government organisations, but also organisations, councils, if you were to combine together to look at these approaches.